In today's lab, we are going to be performing a titration. The purpose of a titration is to determine the unknown concentration of a sample. To do this, you're going to add the volume of a chemical with a known concentration, known as the titrant. And in order to identify the endpoint, you're going to be using what is known as an indicator. Now let's go over some safety precautions. You always want to make sure that you have your hair tied back in the lab, that you are wearing closed-toed shoes, pants preferably to the ankles, but to the knees is okay. You're also going to make sure you have a 100% cotton lab coat, your safety goggles, and your gloves. The materials needed for this titration include a ring stand, a burette clamp, a small funnel, a 250 milliliter Erlenmeyer flask, a volumetric pipette, a pipette bulb, DI water, a waste beaker, our indicator which is phenolphthalein, a paper towel for endpoint visualization, a pH meter, our 3 buffers, 200 milliliters of hydrochloric acid, as well as sodium hydroxide. Now let's talk about the chemicals. So first we have hydrochloric acid. This acid will be going into your flask. So it is a very corrosive acid and it can cause harm to your skin. We're also going to be using sodium hydroxide, which is also corrosive. This will be going into your burette. Now, you want to make sure you are wearing your gloves so none of these chemicals can touch your skin. If it does happen to touch your skin, just make sure you wash your hands immediately and re-put on your gloves. Now onto the procedure. So first you're going to take your burette and you're going to rinse it with deionized water and drain that into the sink. Then you're going to rinse it with sodium hydroxide and drain that into a waste beaker. From there, you're going to take your burette and you're going to attach it to your ring stand using your burette clamp. Then you're going to fill the burette up with sodium hydroxide and then record the initial volume of it. Make sure that you have a waste beaker under the burette tip in case there's any leakage. Then from there, you're going to grab a 25 milliliter volumetric pipette and a pipette bulb, and you're going to rinse the pipette using DI water, drain that into the sink, and rinse it once again with hydrochloric acid and drain that into a waste beaker. Then you're going to measure out your hydrochloric acid. You're going to want to fill it a little above the line on the pipette, and then once it hits above the line, you're going to slowly release using your finger to drain out the hydrochloric acid until it reaches the line. Then you're going to take your 25 milliliters of measured hydrochloric acid and add to a flask. You're going to want to add 2 to 3 drops of your phenolphthalein indicator, and then after that, head over to the pH meter so we can calibrate the meters. What you're going to do to calibrate those is you're going to place them into the 3 buffers to calibrate them. Then from there, you're going to take the pH probe and you're going to place that into your measured hydrochloric acid. You're going to record the pH and then you're going to rinse the probe with your DI water and head back over to your station. When you're at your station, what you're going to do is you're going to place the flask right under the tip of the burette and we can begin our titration. Now, to begin your titration, you're going to add small amounts of your sodium hydroxide, swirl the flask just to make sure the chemicals are mixed, and you're going to keep adding it until you see a splash of pink appear. Once you see that pink appear, you're going to add it in slower increments. You'll know you're at your endpoint when the pink persists. You want it to be the palest pink possible. From there, you're going to record the final volume on your burette, and then head over to your pH meter, and you're going to record the final pH. You want this to be around 7. Then you can start your second titration and then begin cleanup. Now on to cleanup. You're going to want to make sure that all of your chemicals are placed in the proper waste containers, and because we dealt with harsh chemicals, that all of our equipment is rinsed and put away properly. Now on to the calculations for the titration. The goal of this titration was to be able to identify the molarity of hydrochloric acid. To do this, we need to follow a series of steps. Step 1, we need to find the moles of sodium hydroxide. Now to do this, you want to take the mass calculated from the titration and divide that by the molar mass of sodium hydroxide. This will give you your moles. Next, we're going to need to take our moles of sodium hydroxide previously calculated, and we're going to want to multiply it by 1 mole of hydrochloric acid over 1 mole of sodium hydroxide, given that there is a 1-to-1 mole ratio. This will then give you your moles of hydrochloric acid. Next is identifying the molarity of hydrochloric acid. To do this, you're going to take your previously calculated moles of hydrochloric acid. We're going to multiply that by 1 mole of HCl and divide it by the volume in liters of HCl, which then gives you the molarity of hydrochloric acid. Now that the titration is completed and your calculations are done, you should have been able to identify the molarity of your hydrochloric acid.